That's my hope. Let's go in game. Okay, looks like we got 9 viewers, 8 viewers. I don't know. Streamlabs tells me 8 viewers, which tells me 8 viewers. Okay, so we're at 8 viewers. 8 of you enjoy the stream. We'll go as fast as possible, but if you have questions, you gotta put them in the chat. Um, and it's a slight delay, so don't worry. I'll get to it. It's like 5 seconds behind where I'm actually at. Let's make sure my tablet is working. 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 Oh, it's working. Right on there. We can write. Okay. Can everyone see that, or is that too small? I might need to use the thicker pen. Hold on. Hold on. Is that better? Or do you like that one the best? Vote. Which one? First, second, or third? If I use the third, I can't fit as much writing, but you can see it better probably. OGP, OGB votes one. We have a vote for one. Vote for one. We're up to 13 viewers. Welcome, everybody. You made it. 9 o'clock. Less Veggies votes one. Yartango votes two. One is winning right now if you're voting in the stream. One is winning. So right now, we're going for one. Oh, another one. Everyone likes one. Wow. Wow. I guess I'm going one. Aces 818. I love the name. Aces 818. I wish I would get aces when I play cards, but it doesn't happen too often. Doesn't happen. 14 viewers. Invite your friends. I don't care if they're in Mr. Redford's class, they're in our class. It doesn't matter. We might get people watching from last year. I swear we had someone from New Jersey watching the stream. So you don't even know what we're going to get. I guarantee you El Compa is showing up, and El Compa is not in AP stats. And I guarantee you El Compa is going to throw in the chat, and he's in here somewhere, and he's probably watching because I haven't streamed at all this year. This is my first stream in, I don't know, it's got to be like 4 or 5 months. So it looks like one is the winner. If you just joined the stream, we were voting on which writing pen we like the best. People are voting for little number one, which means I can write a lot more. I can fit a lot of stuff. I just want to make sure you could see that. On my computer, it's huge, but you might be watching on your phone, so it might not be huge. So I get it. I get it. So we're going to go one. I'm low key stressing for this test. Oh, okay. Don't stress. Less veggies. Don't stress. We're gonna get you locked in, and you'll be fine. It's confidence. Half the battle on AP tests is just confidence. And remember, multiple choice, there's always two good choices. So it's picking between the two. And there's usually some key words. Like I tell my classes, if they are using absolutes in multiple choice answers, if they are being Sith Lords and they are saying absolutes, then it's probably not the right answer because most of the time we don't have absolute answers in stats. We have maybe, about, roughly. So if it's something absolute, like it's always going to be this, you're probably a little wary about picking that answer choice. That's just multiple choice playing the AP College Board game on multiple choice. Anytime they're absolutes, you're thinking that might be a wrong answer, and that's why it's not true. So just be careful on absolute answers. Now, we're going to start out with, hold on, let me turn this off. We're going to start out with the weighting of the multiple choice. I want you guys to see the weighting. It's no secret. You have 40 questions, okay? So you know you have 40 questions. A few of those questions, remember, are going to be, there's actually sometimes one or two that are test questions that aren't really for your grade. Um, so they are sometimes going to have questions on there that are just testing them out for future tests. So you never know if you're going to have one that's a test that's testing it out. So it doesn't really count towards your score. So you may not really have 40 questions that count toward your score. It may be like 38, 39. So here's your weighting. So what units do you really need to know? You definitely need to know unit one. So we need to go back through mean, median. I haven't done any of that on our review. That's a big section. Okay, you're looking at 4 questions, between 4 and 8 questions you're thinking for that. That's a big chunk. The other big chunk is your probability, which we worked on in class today. For those of you who are at AP um, Lit this morning, you might not have been there. We did some probability review with binomial distributions and random variables. It might not be that complicated. It might be simpler topics than those, but again, 4 to 8 questions. So those are big. Those are two big chunks. You're looking at eight, let's say you have eight there, seven, eight there. Let's say you have seven, eight there. You're already looking at 16 questions maybe out of the 40 are just on those 2 units. So those 2 units are definitely heavyweight. Now, all of these units were second semester. So all you're identifying which hypothesis test you're running, what interval you're running, using t-distributions, running a chi-squared test. Notice chi-squared, you guys, is tiny. Like, you're not even going to have 4 questions on chi-squared. You're going to maybe have two, might be 1 or 2. So you're talking 1 or 2 questions on chi-squared. You're talking 1 or 2 questions on a t-test or a t-interval for slope. Um, so the majority of the inference is going to be about the proportions and your means, which we spent most of our time in doing those. Um, your sampling distribution. Yo, lights went black. First time chat, love the name. Um, so I'm thinking that's sort of all chunked together. Chapter 26 and 27, notice it's not a lot of questions. You maybe will have 2 on the whole thing, maybe 3 or 4, at most 4. So it's not a lot. You're looking at 4 to 8. This one you're probably looking at 5 to 9. So those are big chunks. The next biggest chunk looks like it's going to be collecting data, which is what we're going to go over tonight. We're going to go over collecting data tonight. We're going to go over the unit 1, which is all your describing data tonight. We are going to focus on these 2 parts. Okay, and those 2 parts, right? This is probably another 4 to 7-ish, maybe, on your collecting data. So there's your big stuff. We're going to go over those 2. Exploring 2 variable data, you guys, this is your scatter plots. They make it sound so fancy. 2 variable data. It's just your X and Y. It's just your scatter plots. Can you interpret slope? Can you tell me what R squared is? Do you know what correlation is? Um, all that stuff. Again, it's not huge. We're talking 2 questions to 3 questions. There's not a lot on that. So really your focus, you guys, should be unit 1, unit 3, right? This is all recent stuff. Don't worry too much about this stuff. Okay, Jacob and Chris are here. Oh my God, Jacob and Chris, they're just in here for funsies. Okay, not even in stats. They're just in for funsies, hanging out with Gwyneth. Okay, perfect. So there's your 40 questions. Again, I don't know if you'll have exactly 40 on that will count toward your score. You're going to do 40 questions. It just may be that 1 or 2 are test items. So there's your breakdown. Wanted to give you the breakdown so you had a breakdown of what the actual test questions will be. Now, let's go unit 1. Let's go unit 1. So I'm going to go to this document I put on Google Classroom, and we can talk a little bit about some unit 1 stuff here. So everyone's looking. Glad we got people watching. Okay, What are some things in Unit 1 that were very important? And since you're going to have a pretty good amount, 4 to 8 questions on it. Outliers. You got to find the IQR, interquartile range. Remember, it's Q3 minus Q1. Remember the interquartile range. Q3, don't forget, is the 75th percentile, right? When you have them in ranked order, that's your median of your upper half. Q1 is your 25th percentile. Remember, that is the median of the lower half. So you'd use your median to find the halfway point, and then once you break it into two halves, if you do the median again of the lower half, you get Q1. You do the median of the upper half, you get Q3. So that's your quartiles. If you need interquartile range, you subtract those. And then if you times it by 1.5, remember to find an outlier, Q3 plus 1.5 IQR, and then Q1 minus 1.5 IQR. And that will give you your two boundaries. So you got your upper boundary, we'll call it UB, and your lower boundary. So those are your boundaries, and then and then once those are your boundaries, anything outside of those boundaries are your outliers. So anything outside, outliers. That's how we test for outliers. Remember, you can also use your box plot on your calculator, which reminds me, I didn't open my calculator. Calculator? There it is. Yes, we agree. Yes, sign in, accept. Google. Okay, so remember in your calculator, if you go to box plot, stat plot, go to one of your stat plots, and remember it is this one. That's your box plot that shows you outliers. Decent Dylan, what a name. Naughty Naughty Learly. Okay, so that's going to be your graph that you're going to make. You tell it where to look. Click on that one. Notice it will switch to only have one list that you're looking at, and then you can make your plot. I don't think I have any lists in this calculator, so we'd have to put some numbers in if we wanted to go ahead and do the stat plots. So I don't know how much you're going to use your stat plot, you guys. I really don't think you're going to use it that much. I think a lot of times people have their calculator ready to go and their calculator doesn't get used that much because it's a lot of understanding questions, not calculator questions. So there's your outliers. Remember 5 number summary. I gave this to you on an old test and people still do not know what the 5 numbers are. If you are doing a 5 number summary, you are doing the lowest number, the minimum. You are doing Q1. You are doing the median. You are doing Q3. That does not look like a Q. And you are doing the maximum. Those are your 5 numbers. Standard deviation is not in a 5 number summary. Mean is not in a 5 number summary. Only those 5 things. Medians, quartiles, minimum, maximum. Okay? Those are your 5 number summary. So that's an easy one. I want you to nail those questions. I don't want you to lose out on easy points. When describing data, these are the 4 things you need to make sure you describe. They missed one here. There should be one more thing here. Center. I don't care which center you use. Median, mean, mode, but most of the time we did not use mode. Spread. You could use interquartile range. You could use the range. Remember what range is? Range is just max minus min, which you guys learned a long time ago, probably in elementary and middle school. But that's your range. You can use it. You can say that's the spread. And then shape. Remember, we have right skewed. We have left skewed. Here's a right skewed graph. Here's a left skewed graph. And then we have fairly symmetric when it's pretty balanced on both sides. They forgot to put, you need to do unusual features if there's something unusual. Okay, what are the unusual things? The unusual things are gaps in the data. So if they skip over spaces, you've got to talk about where that is. And the other thing that's unusual is outliers. So if you notice any outliers, bring it up. That's really it. Um, and remember shape, we could have bimodal if you see two bumps rather than one bump. Okay, that can come up on shape also. It's just really rare that bimodal comes up on shape. So don't stress about that. Um, don't worry about your ogive. We are probably not going to get anything of those. Box plots we talked about on your calculator. Let me scroll down some. We got our stem and leaf plots. It's a great way to make a histogram without actually doing a histogram. You just put your stems here. Remember, there should be a key. So if you make a stem leaf plot, you make sure you do a key to tell someone what these numbers mean. Um, so like when they see 9, 8, they know that means 98, or it means 9.8, or it means 980. I don't know, whatever. Okay. If they give you the stem leaf plot, they will tell you what the key is so you know what the numbers represent. Remember, if you want to count how many numbers you have, you do not count the stems, you count only the leaves. That tells you how many numbers because this is just the first digit of the number. It's not actually, so you're not counting those with how many numbers you have. Count only these guys if you want to know how many numbers you had in your list. Normal probability plot we talked about in chapter 27. I don't think you're going to have to worry about it. Basically, if it's a straight line on a normal probability plot, that meant the shape of the distribution is normal. Not a big deal. You don't worry about it too much. Z-scores. Z-scores came up in Unit 1. I think you guys are good on z-scores, right? Are the units usually in order on the multiple choice? No. Good question. The units are not, love the name, Shanny Pants. Okay, so the units are usually not in order. They are mixed up on the multiple choice. So unfortunately, you're not going to know by order which ones are which. Good question, good question. So z-score for your stuff. Um, and then we got explain what we can do for center again, please. Oh, Danica, we got it. Center. Okay. So for center again, let's go back. You could do median, right? Median's great when it's skewed because remember the median doesn't move as easily as the median doesn't move as easily as the mean does. So the median is a good one when you have skewed data. So if I had data like this or like this, it'd be preferable to use the median. And if you have data that's more symmetric, then you're probably going to use the mean as your center. We will probably not use the mode. So mean if it's symmetric, median if it's skewed, use those centers. They will probably give them to you. I don't think you'll be calculating them that much because I don't think they'll be giving you lists of data that much. So that's the center ones. Okay, haven't done those in a while. Um, Remember, you guys, it's a little delayed on the chat, so when I see it, I'll stop and go back. 68, 95, 99.7 rules. First thing we ever learned in chapter 6 on normal distributions. Remember, 68 is within one standard deviation, 95 is within two, 99.7 is within three. That's just rough. Once you learned how to use normal CDF or your Z table, you never really used that anymore. But it's a shortcut if you don't want to use the Z table and you're on the line. Correlation. Correlation is R. Remember, it's strength. It tells us the strength of the linear relationship, not the strength of a curved relationship, linear relationship. How close are all the points to the line of best fit? If you're close, if the correlation is 1, every single point was on the line of best fit, 1 or -1. If the correlation is somewhere between 0 and 1, some of the points are off the line. Remember, if something is zero point 0.7 or higher, very strong. If you're around 0.5, you're moderately strong. If you're around point 0.3, we say you're weak on your relationship. So you can look at, and it doesn't matter whether it's positive or negative. If something has a zero correlation, that means there's no linear relationship, right? There's nothing going on linearly. Doesn't mean it's not a curve. Because look, I can draw you a curve with some points here. There's a nice curve right there. The line of best fit would be like this. So the correlation on this data would be 0, but it's actually not weak because it's really strong for a curved relationship. So you can still be strong even if your correlation is low, because correlation only talks about how it fits a line, not a curve. So that can be how they trick you. Correlation, remember, we never use correlation in total to be comment on the strength. Correlation is one piece of how we can comment on strength, but we still need to look at the scatter plot to be able to comment on strength. So if it's curved, the correlation could be 0. You still might say it's very strong, but it's very strong for a curve. Um, remember on linear data, we'll get to that. I'll get to that. We'll talk about on linear data. Let me open a page. On linear data, when you're describing linear data, even though you're not going to have a lot of these questions, right? There's only two to three probably. Um, you're going to have, um, remember, you have to describe four things. You have to describe the form, which is curved or linear, the strength, how close are all the points to the line, or the curve. I guess it could be a curve too, if it's a curve. And then you need to tell me direction. Is it going positive or negative? And then you need to talk about unusual points if they're there. They're not, there may not be any unusual points. I didn't even know how to spell unusual points. The next Fortnite stream. I don't know, guys. Fortnite stream has not, we need to get bush camping. And I hear it's Star Wars, so I should have to do it. How do you find the correlation coefficient? Oh my gosh. You guys, for correlation coefficient, we do not find it by hand. We do not find it with our calculator. We sort of eyeball it and come up with a guess. So let's say those are your points. They said, hey, what's the correlation? Well, we know it's positive, so correlation will match the slope. It's going to be the same sign. And if you imagine your line of best fit going in here, well, those points are pretty close to the line of best fit. I would say this one is about a correlation of 0.8-ish, right? And that's just ballpark figure. Now, if you wanted to calculate it, then they need to give you the points. And if you want to calculate it, um, you would have to go to the calculator and you would have to put in some points. I'll put in a few points here. 2, 5, 9, I don't know, 1. I want to make a positive relationship. 3, 15, 28. I hope it's not perfectly linear. So let's say those are our points. Turn that on. We go to scatter plot, which is the first one, L1, L2. Remember to do zoom number 9. Okay, wow. Telling me I made an almost perfectly linear thing? I didn't even think about it. Okay, stat, calc, linear regression, L1 x, L2 y's. If you want to save it, you can save it. I'm not interested in saving it. Calculate. Oh shoot, the settings aren't on this one. So there's your slope, there's your y-intercept. Remember, if your settings aren't showing up, R should show up here. And if they're not, we need to turn on our diagnostics. Make sure your stat diagnostics are turned on, especially if your calculator died on you at some time, because it will reset, and then when it resets, it will turn itself off. So make sure the stat diagnostics are on. Let me run that again. And when we run that again, it should show us R. There's your R squared. There's, holy moly right now. I just got an R value of almost 1, and I made up the points at random. What? That's crazy. That's crazy right there. I almost made a perfectly linear model, and I didn't even mean to. So that's how you get your RR squared if you're going to calculate it. I don't calculate it very often, but that's how you could if you had all the points. Remember, most of the time it's from a printout that they give you. You're not going to probably calculate it. Okay. Residuals, remember, always observed minus predicted, not predicted minus observed. Where is the dot? Observed minus predicted. Always observed first. So if you're a positive residual, that meant the point was above the line of best fit. If you're a negative residual, that meant the point was underneath the line. These are all negative residuals. These are all positive residuals because they are above the line of best fit. If I were to draw you the residual, it is that distance, the vertical distance between the dot and the line of best fit. That is our residual right there. So whatever that distance, positive meant you're on top, negative means you're on bottom. You guys, I don't think we need to dwell on that too much because that is probably not a huge deal for our testing purposes. Don't even worry about this. Okay, I'd like to go to vocab. There's some variable vocab right here, variable vocab. Explanatory variables are your X variables. Response variable is your Y variable. A lurking variable. Remember, a lurking variable is a variable that may influence the relationship between two variables, but it is not a variable we are observing. We are not looking at it. It's hiding out there, but it affects the results. Confounding variable are two variables that are confounded when the effects on the response variable cannot be distinguished. So here's the picture I want to show you on confounding. Confounding variable is when you have some x variable, you're looking at how it affects the y variable. Well, there's this variable out there in the world that we're not looking at. We'll call it confounding. Oops, I didn't spell that right. And it is also affecting the y variable. So it is intertied. It is sort of tied up with the x. So I don't really draw it like this because it's not just affecting x. It is intertwined with x and it affects y. And when they ask you about confounding, you would need to say something about how this variable can't be distinguished from this variable, but it affects the y variable. So that's what a confounding variable is. It's something that's out there in the world, affects your response that you're measuring, but you might not be able to tell. There was a problem years ago they did where it was people who ate apples had less cavities, something like that. And they were like, well, what could possibly, it's definitely the apples that are causing less cavities. And they wanted you to get to the point where what's a variable that could be affecting whether you eat apples and have cavities is your general health and well-being. If you're a healthy person, you probably eat more apples. You also probably brush your teeth and take care of your teeth. So a healthiness could be a confounding variable. It's affecting both. It's sort of intertwined with whether you eat apples, and it also affects your dental hygiene. So that was the FRQ one year. They wanted you to come up with a confounding variable all on your own and then tell why it's a confounding variable. So that was that one year. So that comes up. I don't think that's going to come up very often. That's not something that's huge. Let's look at our terms and definition. These are some major things I gave you guys on a handout today. Let's just go over them real quick. Clive the Block. Let's go. He's saying hi to Landon. Landon must be out there. Okay, so what formula would you use to show that two events are independent? Okay, you guys, two events independent. These are the two formulas. One way to show independence is if A and B is equal to the probability of A times the probability of B. Aspen, there he is. There's Landon. He's there. He's there. Um, so times those and you get your independence. But this only works in independence. Or the one that I like to use for independence is A given B should be equal to the probability of A. So that is the best way to get independence. Okay. I love all the first time chats out here. We are killing it. Killing it. If a commercial comes on, I'm sorry, you guys. After a certain number of time, it makes a commercial come on. I might be able to pause it, but eventually it doesn't let me pause it anymore. So you just got to tell me if there's a commercial break, and I'll take a pause break. Okay, how do you find an outlier? We already talked about that. What does central limit theorem say? Central limit theorem says um, if you central limit theorem says, let me show you. I got to show you again. You're going to have to remind you guys because this has been a while. Let me go in our Google Classroom. Let me go all the way back to our sampling distributions. There it is. This is the central limit theorem. Central limit theorem says it doesn't matter what the population looks like. If you pick a big enough sample and you draw it out and you find an average, here comes, boop, and you do that many times, like 10,000, it creates a normal model. That is what the central limit theorem says. It says it creates a normal model if you draw a large enough sample from any kind of population and you find an average of your sample. So those 25 numbers I picked out of here, I then found an average and I plotted it on here. If I do that many times and it makes a normal model, that is because of the central limit theorem. So that's the central limit theorem. I don't think it will come up, but it's there. What does correlation tell you? We talked about that strength of the relationship, how close the points are to the line of best fit. Define coefficient of determination. Coefficient of determination. Okay, if they ask you about R squared, you guys, remember what we say. We say blank percentage of the variation in the Y variable can be explained by the variation in the X variable. That's one way to say it. Or you can actually say the percentage of variation in the Y variable that can be explained by the line of best fit for the X variable. That's another way to say it. Um, so there are many, many different ways that you can say it, but they all mean the same thing. And so that is your R squared, coefficient of determination. Take your R value, square it, tells you the percent of the variation that can be explained by the X variable. It's always that order. Be ready for that. That's more of an FRQ question, or maybe a pick which one is the best on a multiple choice. What is a residual? We did that observed minus predicted. So it's your Y variables, not your X variables. How do you interpret slope? For slope, you always say for every increase in one blank, your blank is your X variable, we predict the Y variable. Oops, should have put a blank there. will increase or decrease about blank, and you fill in your slope. Hopefully you remember that one. Slope is something I definitely think you guys are going to be interpreting slopes. So be ready. Interpret slope. Remember, gray word. You just had it on your last test. Gray word. About, roughly, predict. You don't include that, they will punish you. You will get a partial. So be careful on that. How do you define standard deviation? Standard deviation is what we say the typical distance points are or data is. I guess I could say data because it might not be points. It might be just data. Typical distance data are from the mean, not the median, the mean. How far away are all your points from the mean? That is the standard deviation, typical distance. Don't say average because remember we divide by n minus 1, not n, so we don't say average. Typical distance. Define the median, 50th percentile, right in the middle of the data. This is unit 1, definitely going to be on there. 50th percentile. Also, remember the location of the median, if you have a lot of data given to you, the location is n plus 1 divided by 2. Take your number of data points, add 1, divide by 2. That will tell you where the middle is located. And then you don't have to count your way to it. So if you get 26, you're like, cool, it's the 26 number. If you get 26.5, then it's between the 26th and the 27th number. That's something that people forget. And people also forget 50th percentile a lot. And that you will think something that easy could be a question on multiple choice. Definitely something that easy could be a question on multiple choice. In double blind, who was blinded? Double blind means that the subjects are blinded. They don't know what treatment they're getting. And the evaluators, so the people evaluating them, are also blinded. The only people that probably know are the administrators of the experiment. What does a data point that is at the 37th percentile mean? It means 37% of the data is below that point. That's what 37th percentile means. Okay. What else we got? What else we got? Which of the following are resistant to outliers? Which points don't get affected? Resistant means it does not get affected by outliers. Median, IQR doesn't really get affected by outliers. That's it. That's it. Mean totally gets affected. Standard deviation totally gets affected. Range totally gets affected. Remember, because in all those calculations, you're using the biggest numbers, the smallest numbers, you're using all the numbers, so they are going to get affected by the outliers. That's why we tend to use medians and IQRs. What do all good sampling methods have in common? It produces, this is unit 3, which I said you have a good amount of questions on, produces a representative sample. Representative sample. So it produces a sample that looks like your population. Remember, the whole goal is to have a sample that looks like the population. Okay, that's what you want. So that's the point of our sampling. Do I go over sampling on this? Because if I don't, we're going to hit it right now. Let's hit it. Let's do the sampling right now. Okay, here we go, guys. Sampling. We have simple random sampling, SRS. You're just going to sample by random numbers. Everyone gets numbered. You pick random numbers from a list or a generator and you match them up. And those are the people. Simple random sample. Stratified. We do not abbreviate stratified as SRS. Stratified means you do not go straight to randomly numbering everybody. You actually put people into groups first based on some characteristic. And then remember like freshmen, sophomores, juniors, seniors. We separate the whole school into their grade levels. We pick 10 from each grade level. We ask you a question. That is stratified. Usually that's better than an SRS because an SRS does not guarantee you will have every group represented. I could do a simple random sample from our school. We could have all seniors in the sample. It could happen. We could have all freshmen in the sample. It could happen. We are not guaranteeing that I can get every group represented. Stratified is better because we can get every group represented from all the groups we made. So that might be better because they might have different opinions on what you're sampling. So stratified is better than an SRS. Cluster sampling. These are the two everyone gets confused. Clustered, remember, is when we make groups, but they're mini-me's. They're mini populations. They are not homogeneous for their grouping. Like in these, I picked, oh, I grouped all my ninth graders, my 10th graders, my 11th graders, and my 12th graders. I made you homogeneous groups for your grade level, and then I sampled from every group. Cluster sampling is when we have little populations. So I might pick a math class because maybe our math class has lots of grade levels in it. And so instead of I number all my math classes and I pick two math classes and I go and I survey everyone in those two math classes. That would be a cluster sampling. Cluster sampling is more convenient because you typically don't have to go to all these different places to find your sample. You can go to one or two locations and sample everyone there that's in that cluster. But the thing is, a cluster sample, you have to have good cluster groups that all look the same, so it doesn't matter which group I get. So if I made math teachers, then math teachers have different math classes. One might be AP Calc, one might be geometry. Do those look the same? Probably not. That will not be a great cluster design. We'd like clusters to all look the same, so it doesn't matter which cluster I pick randomly. Channy Pants, on the FRQs, you are definitely going to get a Unit 1 question. You are definitely going to get a Unit 3 question on the sampling or the experimental design, for sure. You're definitely going to get a probability question out of Unit 4, for sure. You're definitely going to get an inference question out of the whole second semester. I don't know which unit it will be from. I prefer to think you're going to get a two sample t-test or you're going to get a two proportion z-test. That's my thinking. They like those ones. I actually think you might get a chi-squared this year. So maybe a chi-squared homogeneity or maybe a chi-squared independence test. Might be one of those. But that's one question, guaranteed. And then that's what we're up to, 1, 2, 3, we're up to 4. So then you got another question that probably involves a confidence interval and maybe something else. Um, there might be a linear regression, but probably not, but there could be. Instead of a data unit 1, they could give you linear regression instead. And then you will have a number 6, which is going to be a mixture of a couple units, and it's an investigation question. So I think you guys are well suited for your inference because it's fresh in your mind. Just pick the right one. Make sure you do all your 4 parts. Make sure you do your hypotheses, you do your um, conditions, You do your mechanics, you write down all your mechanic values you need from your calculator, and then you write a good conclusion. Beta, our pipe, the Matman fire, the beta one is used for the slope. So if you're doing the t-test for slope, you're using beta in your hypothesis. I don't think you're going to get one of those. So, um, but it could come up. Good questions, good questions. Man, Landon has fans in the chat. Several seaweed. Let's go. Okay. Um, so these are the three. Was there another one? Oh, there's another one. I forgot one. We have systematic. Systematic, remember, one of my faves, probably one of the easiest. You randomly pick a starting point, and then it's like every 10th person, every 15th person, every 20th person. You just have to do the randomization of where you start. And then after that, it's every whatever you decided, fifth person. And then remember, multi-stage is if you do multiple sampling methods together. So maybe you do a cluster sample on the first level, but then on the second level, you don't want to ask everyone in the cluster to do your survey. So then you might randomly select from the cluster, or you might do a systematic. You might go to each floor and do every fifth room. I don't know. Maybe you're surveying a dorm building. So if you mix your sampling methods and use more than one, then it's called multi-stage. When you do random assignment, what is the purpose? Random assignment is used to um, remove bias. Well, we'll not say remove because we're never going to be able to remove. I'm not a Sith Lord. I can't get rid of everything. To reduce bias and distribute confounding variables into all the groups. That's sort of the point of random assignment. Reduce bias, okay, by not us favoring who we're picking, and then distributing the confounding variables into all the groups. What is the purpose of blocking? So blocking, what is purpose? Blocking is to control a variable that you know affects the response variable. So this is an experiment, and if you're doing an experiment and you know that some variable that's out there that you're not controlling might affect what you're measuring in your response variable, you might want to block it. So what you do is you separate people into groups based on that variable, and then you run the experiment on all the groups, basically. So like, let's say I'm doing an experiment on how well this new drug is helping you heal after a surgery. Okay. Well, there's lots of things that affect how well you heal after a surgery. Could be your age, could be whether you're a smoker. I don't know. You pick something. You're like, okay, I think smoking affects how you heal after a surgery. So if you think smoking has an effect and you want to block it out, I would take my people that had surgery and I would separate them into the smoker group and the non-smoker group. And then once I purposely separated them by that variable, then I would do my random assignment into my treatments, right? So this one might get the new drug, this one might get the old drug. And you do it within each of the groups. So they get both treatments are showing in that group. And then what I do is I just compare how they did within the smoker group because I know the smokers are going to heal a lot differently than the non-smokers. And then I run the experiment over here in the non-smoker group, same experiment, assign some of them to treatment 1, assign some of them to treatment 2, and then compare their results, but only compare them within that group of the non-smokers. That would be blocking. You blocked out the variable of smoking in affecting your response variable. So it's basically running a lot of experiments, okay, with a lot of different groups. Blocking is very similar to stratifying on sampling. And remember the experimental designs, there's completely randomized, which means we don't do anything. We just randomly assign you into your treatments, okay? Flip a coin, whatever it is, we just randomly assign you. So that's one design. That's the worst design, remember. And then there's randomized block design. And that is when we do what I described below, which is a better design because you're controlling some variables. And then the best design, remember, is a matched pair design. And matched pair might be that you match someone up with a twin or someone similar, or it could be you give that one person both treatments in random order. That's also a matched pair, even though we don't have a pair of people. That is the best design. So best, this is better, this is good. So good, better, best. If you can design an experiment as a matched pair, that is the way to go. If you can't think of a way to do it as matched pair, or you can't give both treatments to the subjects, then you probably have to do a randomized block design. Can't think of a way to block a variable, or you can't think of a variable that you'd like to block, then you're just doing completely randomized. That's sort of the order that those were your different experimental designs. So that was all Unit 3. You got sampling in Unit 3, you got experimental design in Unit 3. Those are your big parts of Unit 3 right there. So hopefully that helps with Unit 3, because again, I think you're going to get some questions. The other thing on Unit 3 that they like to ask is they might talk about bias. Bias is when you favor certain outcomes or opinions. By how you're picking people, how you're assigning them into the groups. Somehow you're favoring a group and their opinions, and you have more of them in your sample or whatnot. That would be bias. You might create bias within your sample. You might not even do it on purpose. It could be accidental that it's being made and you just weren't paying attention and you have bias in your sample. We try to reduce it. We cannot get rid of bias. But whatever you do, you can't get rid of it. You can just try to reduce it. It's impossible to get rid of. What does 95% confidence means? Remember, that means if you do it many times, over and over and over again, 95% of the time, your inter oh my God, I'm coughing. Your interval will capture the true answer. That's what that means. 95% confident. Um, let's see. Talked about Unit 3. We talked about that one. Hit that one with shape, center, spread, mean, median, standard deviation, mode, normal distributions, box plots. Oh, remember on a box plot, um, remember what everything is? Stuff I just assume sometimes. I shouldn't assume that people all know. Remember, scale goes here, so there should be a scale, okay, for the box plot. This is your minimum. This is your Q1. This is your median. This is Q3. This is your maximum. Now, here's the cool thing about box plots. This is why I love box plots. 25% of your data is between Q3 and the max. Because remember, that's the 75th percentile, and that's the 100th percentile. So there's 25% of your data right there. Q1 is the 25th percentile, which means there's another 25% of your data in this tail. There's 25% of your data between this line and wherever the median is on the box. And there's another 25% in this part of the box. The whole box is 50% of your data. Okay? Box plots are awesome because they show you so much information with the percentiles and what. So I love box plots. So just that's something from Unit 1, help you out too, because they love box plots. They will definitely give you box plots on the test. We talked about collecting data with Unit 3 and our sampling and bias and that kind of stuff. Talked about probability in class. Sampling distribution was basically the central limit theorem. Let me go over that real quick. You'll get a few questions on it. So sampling distributions. Okay, so if you're in proportions, remember this is the foundation for everything we do in proportions. The sampling distribution, which means if you sample many times from the population, we know the center of the distribution will be the true proportion. That is the true proportion. And then the spread, remember the spread, the standard deviation is the square root of PQ over N. That is going to be your spread for that distribution. If you do your sampling many times from a population, the center should be P and the spread should be square root of PQ over N. We did the ghost problem. Remember the ghost problem in class? Ah, we got a nice chat message. Graduated 2 years ago. Do I still have to take this exam? No, you do not. You graduated 2 years ago. You are done. You're just enjoying it now. Maybe it will help you in a college stats class if you have to take. Clive the Block says, yes, you need to take the exam. Um, and then that's for proportions. You're trapped. You're trapped. You're never leaving. Ah. I was worried I did not study enough. You guys are cracking me up in the chat. Late at night, we're having too much fun doing stats. So for means, this is the model for means. If you do a mean over and over and over and over and over again many times, the middle will be the true answer, the true average of the population. The spread, though, remember this is the unique one. The spread is the population standard deviation divided by the square root of n because the spread gets less. Spread goes down. So these are your sampling distributions. Theoretical, purely theoretical, because we don't even use this one when we're in means because we end up using the t-curves. So we don't even use this one because we end up using a t-curve. Because remember, for means, we never know what that is. And that's the population standard deviation. And we usually don't know that number, so we don't usually use a normal model. But in theory, it would be a normal model if we did know what the spread was for the population. So that is the population proportion. This is the population mean. So that is what we call our sampling distribution. We did them on the first day of the unit that started in chapter 19, 20, 21, 22. That was the first day of notes with the ghosts problem. And then this was with the applet problem I showed you, where it puts the little blue curves. That was the very first day of notes for chapter 23, was our sampling distribution. So that's what a sampling distribution is. If you see that come up, it's the theoretical model we use. Do you think we need to memorize all the different equations for hypothesis testing interval? Addison, I do not think you need all the formulas. I think they're on your sheet, and I only think on multiple choice, okay, not even a lot of them. Maybe one or two multiple choice. You might get a formula question, but if you can use your calculator really well, you're not going to need it on FRQs at all. So it's only going to be on a multiple choice. Can you quickly explain the difference between a t-test and a z-test? Okay, so here we go. Z-test and t-test. So when we're in means, we use a t-test. And the reason we use a t-test is because we need a bigger tail, because we do not know this standard deviation of the population. And when we're using our t-test in our mean stuff, because we're not using the standard deviation of the population, we're using our null hypothesis as our middle, and then we don't know the standard deviation, so we're using that. We change the formula, remember, and we use the standard deviation of the sample divided by the square root of n. Because we are using this formula, we have to do a t-test instead of a z-test. We don't ever use the only z-tests we do, you guys, are the one proportion z-test. So when you're in proportions, yes, you're using a z-test. You're using a normal curve because we can figure out the standard deviation using PQ and N and the two proportion z-test. So for those two, we do use a z-test. For means, we don't use a z-test ever because they do not give you the sigma of the standard deviation of the population. So we are always going to use a one sample t-test for our means. Now, the formulas that Addison, I will tell you the formulas I think that are probably the easiest ones to use that might come up is for the proportions, the confidence interval formula is your p hat from your sample plus or minus z critical times the square root of p hat q hat over n. I think that one is attainable. I think that one could come up on the multiple choice. Um, I think it's more likely you get an interval formula than a hypothesis test formula. That's the interval formula for a one proportion z interval, not test, but that would be the one proportion for the z interval. Um, the other one, right, in the t-test, it's going to be the mean of your sample plus or minus t critical, and then you're going to use the formula standard deviation of the sample divided by the square root of n. You're going to use that for your one sample t interval. Um, those those I think are easy for us to remember, and I think they might come up. I think those ones, if you're going to pick ones that might come up, it might be those. I don't see the test ones coming up that that much um, because we don't usually run the test by hand. I'll be totally honest. I don't run it by hand very often. And if it's multiple choice, Addison, I bet you can stare at those answer choices and you can probably figure out there are going to be obvious wrong things in each one except for one. I think you could probably figure out what they messed up on because they're going to change. They're going to have the wrong z critical or the wrong t critical, or they're going to put the wrong standard deviation calculation, or something's going to be messed up. Remember for the one proportion z-test, to get your to get your z-score, it's your sample proportion minus your null hypothesis, which we think is the, right, what is the true middle, we think. And then you're going to divide by your p hat. Nope, nope, I lied. It's not p hat. That's what they'll probably try to mess you up. It's not p hat for the test, because the test, you assumed that this was the true answer. So it's going to be the null hypothesis number, null hypothesis failure, divided by n. That's probably something that they would put incorrectly. They might put the p hat in there, because in your null hypothesis, you would put that p equals whatever number they told you was that they thought the true proportion. And you were trying to prove probably that it was greater or less than or whatever it was. That, I mean, that formula is not terrible, but they could mess it up because they could put p hat down here instead of the null hypothesis down here. When you're using the hypothesis test, it's always whatever the null hypothesis is, should be the one. Whereas over here in the t-test, it's a little different. It's your mean of your sample minus the mean that we think is the null hypothesis, right? Because we've already written somewhere that the mean is equal to some number they gave you. And we're going to try and prove that the mean is bigger than some number they gave you, or less, or not equal. But the bottom will be, the bottom's still going to be this. The bottom on this one is still going to be the same as what you wrote in the interval, because we don't have a number here to put in. Like this one, we assumed this was the true answer, so we used it on the bottom. This one, we didn't assume anything for standard deviation, so we just had to use our sample again, which is why we're using a t-curve and not a z-curve. That is why. It's because this is not the real standard deviation of the model. So that's why we're using a t-curve. T-curve has fatter tails, less stuff in the middle. Fatter tails, less stuff in the middle. It increases your variation a little. So those are probably the basics. I don't want you guys getting hung up in all the formulas. I don't think many of the questions are going to be formula questions. So I don't think that's a beneficial for your time, because I think at your time you're trying to do, you're trying to focus on the very, that sometimes I worry about you getting those formulas, you get stuck in the weeds on the formulas. And the formulas are on the sheet. You could always look them up if you forgot. Um, so if I open a sheet, let me open a sheet. AP Stats, FRQ 2020. Okay, formula sheet. They are here on the second page. Well, first they give you the test statistic, which doesn't really help because they just tell you statistic minus parameter over standard error. Okay, well, yeah, of course that's what it is for every single one, but it doesn't tell you what all the stuff is. So that's where I go here. If you're in the one proportion, that's P, that's Q, that's N. That's for your sampling distribution. So this is the theoretical stuff. Stuff that's real is the stuff over here. P hat, Q hat over N, that's your standard deviation. Now, it doesn't really tell you that it's, no, it doesn't really. It just sort of gives you the rough ones. So it's not the greatest formula sheet in the whole world, and you guys do not get hung up on all this stuff down here. You're not going to need to know any of this stuff. Don't even worry about that. This is just, I look at it if I forget to do standard deviation divided by square root of n. I don't think you're going to have to do the two sample ones by hand. So let's not even get stuck in the weeds on the two sample ones, because I don't think you're doing those by hand, but don't stress about those by hand. And who cares? If it's one question on multiple choice, whatever. You do an educated guess on it. You do the best you can. It's one question, okay? your FRQs, you're not going to need that. Um, so do your FRQs exactly like you've done all your other FRQs on our stuff. Okay, don't let it hang you out. Um, do you want to go over questions? I have some questions. That's what I wanted to hit with our vocab and stuff. I did post a vocabulary Quizlet on the Google Classroom. It's pretty cool. It reminds you some of the stuff I was talking about. So if you're like very concerned about vocabulary, you can look at it. I don't think, I'm trying to see if there's anything that doesn't fit in here. Because of course I stole it from something. Um, looks good. I don't think you're gonna have to worry about frequency versus relative frequency. Relative frequency just means percentage. It's their fancy way to say what's the percentage. Um, Greek symbols, why, no, we don't need that. Statistic comes from a sample. Parameters about a population. Median, yep. Trimmed mean, we never did that. Don't even worry about that one. Don't even look at it. Standard deviation, yep. Yep. Variance, square of the standard deviation. Remember that. That's something that's going to come up. Square of the standard deviation. IQR talked about it. High and low outliers talked about it. Empirical rule. That's your 68, 95, 99.7 rule. Z-scores, you guys are awesome at Z-scores. You talked about our 5-number summary. Box plots, skewed left, skewed right, scatter plots, R, R squared, residual, good. Transformations, don't even worry about. So there's some good stuff on there. Let's look at these multiple choice. So I'm going to start with the number one missed question on here. And it looks like it was 21. 20, 30, 21 and 30 were the winners. Yep, 21, 30. Those are the biggest missed questions on that practice test I gave you. So let's look. Here we go. 21. Let's see what you guys picked. Let's see what it was. I wish I could increase the view. Sorry, you guys, I can't get it to zoom. It's blocking my. Hold on, let me move my little camera. It's not blocking it. Whoop, we're moving it over. Whoop. I switched sides of your screen. Okay, there. Okay, so now I'm not in the way. So let's look. Gosh, I can't even scroll down anymore. Um, Researchers working for a certain airline are investigating the weight of carry-on bags. The researchers will use the mean weight of a random sample of 800 carry-on bags to estimate the mean weight of all carry-on bags. Okay, that's a pretty big sample. Which of the following best describes the effect on the bias and the variance of the estimator? Wow, what a fancy word that is. If the researchers increase the sample size. Okay, so the basics of it, forget about all these other fancy words. They said, hey, we're taking the sample size from 800 to 1300. What does it do? Well, for bias, decrease bias, decrease bias, bias remains the same, bias remains the same, decrease bias. Okay, did they tell you how they were doing the sampling? No, they didn't tell you how they're doing the sampling. They just said we're going to increase the sample size. We're not going to change the way we sample. We're just going to increase it. If they had bias in their sample of 800, whatever the bias they had in there, they're still going to have it on the 1300 because they didn't tell us that they changed how they did their sampling. They didn't say we went from convenience to a random sample, which would reduce bias. It can't remove bias, but it could reduce it if they had told us they changed the sampling. They didn't change the sampling, so there's the whatever bias was there is still there. That's why the bias remains the same. The sample size should lessen variation. So I know they're calling it all these fancy things, But variance is just a measurement of variation, just like standard deviation is a measurement of variation. Variance should go down because when you increase sample size, decrease variation of means, especially on means, right? Means, remember, sigma divided by square root of n. So if you increase n, it's going to decrease that spread measurement. So there's that one. So 6, you got it right. 6, you were very close. You picked up the bias will remain the same, but the variance will increase. And 4 people said variance remains the same, bias will decrease. A lot of people like to say the bias will decrease when you increase your sample size. But I do like that 12 of you were close. C and D, it was close on that one. So that one, that's just, that wasn't that bad. That wasn't bad. That was, you know, it was just a harder question. And then where's the other one? I hope I can do these ones. That's why I always hope. I haven't even looked at them. I mean, I looked at them when I made them, but I haven't looked at them to see which ones were missed. Describe the sampling distribution. Oh, okay. So this is like the very first day of our units. So might be a hard one for people. Based on records kept at the gas station, the distribution of gallons of gas is skewed to the right. Okay. Mean is 10, standard deviation is 4. They did a random sample of 64 customer receipts, and they found the sample mean of gallons was recorded. Suppose the process of selecting a random sample of 64 receipts and recording the sample mean number was repeated a total of 100 times. Aha, there's the kicker. They did the sample 100 times. So they just told you we just created a sampling distribution, which is very similar to what we did in class when you guys did like the ghost problem. And we then put them all on the board to see what everyone got. We did it 30 times. Well, they just did a sample of 64 receipts, but they did it 100 times. What is the best description of the dot plot that created by that? So if you do that 100 times, you've created a sampling distribution, and it will be normal if the sample was large enough, random, less than 10% of the population size, right? All those things. Well, it was random. 64 receipts every time. That's way more than 30. So even though they told you the distribution was skewed to the right, they picked more than 25 or 30. So they picked a fairly big sample. So we know we're okay. We're going to have a normal distribution. And let's see. So the normal distribution means it's D or E. So you got it down to 2, which is what we want. We want you to get it down to 2. See, a lot of people picked skewed right, skewed right. You forgot we're doing it 100 times. We're doing that applet. They basically just told you, hey, we're doing the applet without doing the applet. There's your skewed right. We picked a sample of 64. We did it 100 times. This is what it created, a nice normal model. Um, so where did I go? So we know it's normal. The mean is 10. Standard deviation here is 0.5, 0.4. So, well, standard deviation of the population was 4. We did a sample of 64. So the new standard deviation is 4 divided by the square root of 64. Not 4 divided by the square root of 100, which was what some people might do. Because the sample size wasn't 100. The sample size was 64. The 100 was we just did it 100 times, which is really irrelevant. We don't really care how many times we do it. We just want to know that we did it a lot of times. So don't, yeah, don't let that distract you. That was a distractor right there that they were doing. So 2 of you were close. 6 you got it. That was awesome. Okay, those were the 2 heavily missed ones. If you're here and you're watching, there's still 17 of you watching at 10:30. Can't keep you up too late. You got a test in the morning. You got to be there at 7:30. Um, is there a specific one? Is anyone is watching and you have one that you just want me to talk about? You put the number in the chat and I will look at that one. but you tell me. Number in the chat if there's one you want to see. Because it might be even one that a lot of people didn't miss. I mean, it doesn't matter to me. I'll pick any of them. They're all good questions. The next one I would pick is I would pick the one that has 11s. 11? 11 had 11. And 23. 34. 34 you might be better at now that we practiced today. That probably is a question that had to deal with today. What is the expected value in the standard deviation? Oh, this is a hard question. This is a hard question. Guys, I don't think you're going to get one this hard, but this is a hard one. It's fun, but it's hard. So I'll show you this one. But I actually think it's too hard, but I'll show it to you. Great, they don't even show E on there. So the player is getting 5 points for each card that's moved to correct position. Players penalized 10 points for each minute the game is played. Let the random variable X represent the number of cards moved, and let the random variable Y represent the number of minutes. Mean and standard deviation of the random variables are shown in the table below. They wanted us to figure out the points. So they're getting 5 points for this, and they're losing 10 points for these. So I need to turn these moves into points. So let's focus on expected value. So the expected value for the X for your moves, expected number of points, you're going to get 5 points, and we did 9.5 moves. So that would be the expected value. So 5 points times 9.5 moves. 47.5. 47.5 points will be your expected value for the moves, and your expected value for your time. You're going to lose 10 points, and we took a mean of 5.4 minutes. So that's going to be negative 54 points. So negative 54 points for your moves, for your time, positive 47.5 points. So if we combine these two groups together, because our total points is going to be these two combined, you're going to get 47.5 minus 54, which is what? 6.5 negative? So my guess is the middle is negative 6.5, which the cool thing is you are down to 2 just by knowing how to do middles. Now, standard deviations are harder, right? Standard deviation, when you multiply points by your middle, remember when you multiply, standard deviations also multiply. So the new standard deviation for your X will be the 5 points times your 12.9. So there's your new standard deviation. 5 points times 12.9. 64.5. So there is your new spread in points. So that spread measurement is in points. The spread measurement for the Y in points is negative 10 times 1.1. So that's negative what? Negative 11. So there's your spread. But remember, we are not allowed to add spread like that. Can't just add those together. We have to square root 64.5 squared plus negative 11 squared. That's the weird thing, remember? That's the weird thing. Got to combine variances. 64.5 squared, 11 squared. 64.5 squared plus, I don't need the negative. We don't need the negative. You know it's positive. Square root that. 65.4. Please be right. Please be right. See, I'm just fumbling in the dark on that one. Just fumbling in the dark. We got it. 65.4. So it's a weird one. It's a very weird one. It basically made you multiply everything, which what do you do on means when you multiply? What do you do on spreads when you multiply? Remember, when you multiply by constant, the middles will multiply by constant, the spread will multiply by the constant. But then when you combine your middles, easy, you just combine your middles. But remember, we cannot just combine standard deviations. You have to combine variances when you're combining standard deviations. So be careful. That's the kicker, even though you would have had a 50-50 shot if you were able to just work on the middles. So that's the nice thing about multiple choice sometimes. Get it to 2, which is what College Board is evil for. They will get you to 2, and then it's sometimes hard to guess. Are there any numbers? 14 of you are still here. Are there any numbers you would like to see? If there's any questions, this is your chance. We've been on for an hour and a half. We're up to 504 followers now. Woo woo! 504 followers. You guys are amazing. I hope you didn't get to have to watch too many commercials. I didn't see if you got commercials or not. My daughter is texting me right now to see if I'm awake, asking me if I'm awake at 10:30. Of course. I'll tell her, of course, I'm streaming. Come watch. Let's see if my daughter shows up. I don't think she will, but we can check. I'll tell her it's review night. We were up to 30 viewers, you guys, and we didn't ever see El Compa tonight. I'm a little shocked right now. I hope El Compa's safe because he didn't show up in our stream tonight, and I'm a little sad about that. He's at every stream I've ever done. Let's see if my daughter's going to show up. She's laughing at me right now. Clive the block. She's laughing at me. Does that mean she's going to visit? Let's see. Let's see if she comes and shows up. See if she gets here. Now we're just chatting, guys. This is your chance. Any questions you want answered, this is your chance. Pricage, he subscribed. We have a subscriber. Choo, choo. Did you get the pop-up? Did he get the pop-up? Because I made a video a long time ago that pops up when I get the subscriber. It's a little old though. It's like 2018. You notice my son is a sophomore and he's like 9 years old in that video. So she says she doesn't have Twitch. How can my daughter not have Twitch? Like, what is going on in this world? You just go to Twitch. You can watch without having a Twitch. I'll tell her she can send me question in chat. She doesn't know everyone's hearing her question right now. If it's appropriate, I'll tell you her question. Let's see what she says. Let's see what she says. She wants my opinion. Oh, we got a long question. She says she's not asking me in chat. Not asking me in chat. She didn't want to send us a message in chat. What happened to my thing? Oh, I left my stream thing. Left my stream for a second. I was all scared. Everyone likes to say bye to Landon. Landon. And we got one subscriber, Ryson. He's the true one. Ryson's the true one. We got a subscriber out there. Use your Prime. Prime is a great way to do it. I subscribe to myself with Prime, right? Might as well pay myself. Amazon Prime wants to pay me. I'm okay with that. So I pay myself. I pay myself. What is it? I don't even know. 250? $3? I don't remember the amount is. I haven't checked recently because I never stream. So you guys need to get a good night of sleep. Oh, I will say, eat something good in the morning. Eat some protein. Protein is supposed to help your brain function. So get some protein in you. Eat some eggs for breakfast. Get up early. Don't get there late. Don't be rushed. Be relaxed. Trust your gut when you're on the test. Don't question yourself so much, you guys. Don't be so overcritical about yourself and just trust your gut. You've been doing these tests all year. You're not going to get much different stuff on there. It's going to be the same. Get it down to two choices. Pick something good when you get it down to two choices. Yes, less veggies is more confident. That's what we like to hear. 8 a.m. is rough. You guys, I'll be honest with you. My 10 years, right? I started this first exam was 2016. You're the first time to do it in the morning. They just changed it this year to morning. It has always been an afternoon exam and it has always run pretty long. So, like, students did not get out till close to 4 o'clock when they ran it in the afternoon. So, hype train incoming. We got a hype train. I don't know what a hype train is, but we got a hype train. What? Decent Dylan. Subscribe with Prime. Decent Dylan. We got a hype train. We're at level 1 on our hype train. We are amazing. My gosh. Level 1 on hype train. It says if I increase, I have 4 minutes to increase my hype train. Don't ask me. Don't ever, I'm never on Twitch that much. But yeah, I mean, it didn't used to be morning. It sucks. Morning sucks. I hate mornings, you guys. Look at me. I'm up at 10:30, 10:50. I'm a night person. I don't even like mornings. Morning classes are terrible. When you're in college, you don't want a morning class. Take an afternoon class. Take 11, 10. I didn't like to have anything before 10 a.m. if I could avoid it. One time I had mechanics of machinery. Oh my gosh, it was terrible. It was at 8:30 in the morning, and it was terrible. Oh, it was the hardest class too. Oh my gosh. Who do you think will be the next pope? Ooh, my vote is on who is that? I think I'm it's a hard choice for me. I sort of wonder if it's going to be this cardinal from New York. I think it might be I saw him on the news channel talking and he seemed pretty eloquent in his talking. And I don't know. I don't know if he has a chance or not. But that's an interesting one. But I've heard people talk about is it going to be our first African pope? Um, Will it go back to Italians? Because we have usually a lot of Italian cardinals or popes. It'll be interesting. All I want to know is, Clive the Block, did you watch Conclave, the movie? Because that is a good movie. Even if you're not into it, it's interesting. And it shows you amazing, like what could be going on right now that we do not even know about because everything's a secret. Conclave was actually really good. So if you haven't watched Conclave, I think it's on Peacock. Pretty sure it's on Peacock. You should go watch Conclave on Peacock. Oh my God, the ending on Conclave, you're right. The ending was absolutely, did not expect the ending at all. At all. I thought I knew what was going to happen. I thought what everyone thought. I don't want to spoil it for people who haven't seen Conclave, but man, it was not what I expected at the end. But so much better than I thought the movie would be. I really thought it was going to be a boring movie, and it wasn't boring at all. It was um, very left you on edge. Like, what was going to happen? What was going to happen next? Even my wife watched it, and she was like, "I'm not into watching that," and she was even excited to watch it and liked it. Yartango, thanks for incredible stream. Yes, six on the AP exam. Six, six. Here's the thing. I need more fives, guys. Let's get our fives. Lock in tomorrow. Give me some fives. I want more fives this year and fours. Let's do it. Let's see some awesome numbers on there. But trust yourself and just relax and get a good night of sleep and rest up and don't be late to school tomorrow. I'm excited because we also get to see new FRQs this weekend. Yes, eat a good breakfast, sleep well, less veggies. That's what I like to hear, making me feel good. Let's do this. We're going to rock this test tomorrow. Confidence, go in there with confidence. Tell everyone you see, we're going to do this. We're going to rock this. We're prepared. You've learned everything you need to learn for that test. You go in there and you rock it. You know everything you need to know. Okay, we did not leave anything out. Go in there, trust your gut, and don't stress about number six on the FRQ. You get A and B on number six, and you be happy with that. And if you can get C, D, and E, then you did amazing. And if you don't get C, D, and E, then don't worry about it. There's always weird stuff. Okay, you 12 viewers, good night. I'm going to sign off. I gotta go eat something and drink something. My throat is dry. I talked for an hour and 41 minutes. That's just like class, I guess. Um, Thank you for the subscriptions. We liked them. We got